But there's something else. A hot, white anger. The macrophage knows what it needs to do. Kill. Invigorated, it throws itself against the enemies once again. All over the battlefield, this begins to happen. Meanwhile, the second group of helper T cells was working on activating another line of defense, B cells, your antibody factor.
B cells, they spread antibodies so that the B cell. So technically, the main thing is the macrophages. The helper T cells help wake up the macrophages, but the B cells spread antibodies, and then to help the macrophages eat the things, the bacteria. So technically, yeah.
Antibodies are protein superweapons that look like tiny crabs with two pincers to grab enemies. Just like the helper T cells, there are B cells in your body that are able to make just the right antibodies for every possible enemy.
Really?
And the helper T cell is looking for exactly these B cells. After a day or two, the right B cell is found and begins to clone itself. As soon as enough clones have been made, each B cell begins pumping out up to 2,000 antibodies per second. About a week after you injured yourself and bacteria invaded, your second line of defense finally arrives in full force. The tiny army begins to saturate the battlefield, pinching and stunning desperate bacteria. The antibodies clump them together and make them unable to move or fight, while your soldiers massacre the defenseless victims. The tide is turning fast. As the last enemies are cleaned up, your soldiers realize they are no longer needed and begin to kill themselves to save resources. But not all of them. A few helper T cells remain and turn into memory cells. They will guard the tissue for years, making sure the same bacteria will never again gain a foothold here. B cells will stay alive and keep producing a low amount of antibodies, making you immune against this bacteria, maybe for the rest of your life.
One of the most fascinating systems of all is the immune. It features cells in your body that work day and night together to protect you from a constant threat of pathogens trying to bring mayhem. And most of the time, you don't even know it. Most of the time. By pathogen, I could mean a lot of things. A lineup, viruses, bacteria, fungi, protists, parasitic worms. We could go on. Your body has external protection against these things, like your skin. We call that a first line of defense because it's the first line against letting these pathogens inside your body. Mucous membranes, too, like the lining of your nose, will keep pathogens from getting inside. This first line of defense is non-specific because it's not selective about what it blocks from getting into your body. But this is all not foolproof, and sometimes they do get in.
Huh,
and
I made it.
Your immune system has all kinds of ways to deal. After all, this is...
And then that guy, he goes into a cell and then, wait.
Not its first word.
And I'm gonna tell me something. That guy goes into a cell and makes it an infected cell, and then that cell goes careless and just says, oh, sure, I'll make it. And anyway, it's kind of simple. So then they just make it, and then more and more just poof, and then till the immune system actually beats the stuff. Okay.
Sometimes they do get in. And when they do, your immune system has all kinds of ways to deal. After all, this is not its first rodeo. So let's say they break through our first line of defense.
Ouch.
Well, the second line of defense includes the inflammatory response.
Boop.
To explain it very simply, let's say you step on a sharp stick, and there's some bacteria on that stick, in your foot. The initial damage of this stick into your foot can cause certain types of cells, such as a mast cell, to react. These cells are filled with substances that work with allergic responses and inflammatory responses too. One substance that they contain is histamine. If they are triggered to release histamine, the result is that this will cause blood vessels to dilate, meaning they widen near the injury. Histamine also contributes to making these blood vessels leakier. The dilation and the leakiness of the blood vessel makes it easier for many types of white blood cells, such as certain types of macrophages, to reach the area. And macrophages do what macrophages do best.
So the macrophages main objective or main job is to kill enemies. The secondary job is that to activate cells, communicate, and cause inflammation.
And secondary duties. Now the immune system looks like this. Now the interactions. Isn't this complexity just awesome? For this video, we will only talk about these cells and ignore the rest. So what happens in the case of an infection? It's a beautiful day when suddenly a wild rusty nail appears and you cut yourself. The first barrier of the immune system is reached, your skin.
Rusty sharp.
Nearby bacteria seize on the opportunity and enter your wound. They start using up the body's resources and double their numbers
Rude! They steal our resources? I didn't know that. I forgot.
about every 20 minutes. At first, they fly under the radar, but when a certain bacteria population is reached, they change their behavior and start to damage them. First of all, your guard cells, known as macrophages, intervene. They are huge cells that guard every border region of the body. Most of the time, they alone can suffocate an attack because they can devour up to 100 intruders each. They swallow the intruder whole and trap it inside a membrane. Then the enemy gets broken down by enzymes and is killed. On top of that, they cause inflammation by ordering the blood vessels to release water into the battlefield, so fighting becomes easier. You notice this as a very mild swelling. When the macrophages fight for too long, they call in heavy backup by releasing messenger proteins that communicate location and urgency. Neutrophils leave their patrol routes in the blood and move to the battlefield. The neutrophils fight so furiously